Welcome to my talk about intelligent material flows in manufacturing and intralogistics with some real-world applications at VW and Schaeffler. So, my name is Wolfgang Heckenberg. I'm a CEO and co-founder of synchronize. We are hosting the mobile robot application here at the AWS booth. Welcome to visit us at any time here. And I want to talk about how we use AWS cloud technology to really boost intralogistics in automotive, but also in e-commerce, in food and beverage, and all those other industries. Before I founded synchronize, I was 10 years with the VW group, being responsible for shop floor IT and Industry 4.0, so digitalization of manufacturing. We are actually a company coming from Hannover, so this is a home game for us. We were founded in 2019. Here in Hannover, we have customers all around the world, especially in Europe and now in Asia. And as you see, we are heavily coming out of the automotive industry, but now expanding into other industries as well. When we looked at the industry, we saw some key developments. We saw some things that were not going on in the right way, and we saw some developments we want to address with what we are doing at synchronize and what we want to do with software. So one thing is that intralogistics is the biggest leverage in the warehouse and the factory. This is pretty much everywhere in the world, but especially in Western Europe and the US. Intralogistics is so neglected in all the automation approaches since, a lot of things, a lot of money was invested into supply chain optimization, into the production processes, but intralogistics oft is the wild, wild west. So this is something we wanted to address. The mobile robot market, and I think that is very obvious to people that are in the industry, is growing on a very high rate. You know those big applications in warehouses, but also in factories, in more diverse warehouses. Mobile robots are strongly growing. The average fleet size of mobile robotics is increasing, okay? So we have more and more robots, I will stress that in a couple of minutes, in different shapes and forms, so more diverse and really massively growing in sizes. Manually vehicles still make up over 90% of intralogistics, so that's a thing that you have to see and understand in the industry as well. So that's a very important part we have to address as well. And then our last hypothesis was software is really the key. So obviously we're here at AWS, but software is really the key for the industry, for intralogistics, a clear separation between back-end software and the hardware over standardized interfaces. And that's why we created synchronize, and that's why we created our software solution to really revolutionize what we are doing in-house in intralogistics. That means with mobile robots, with manually driven vehicles, and orchestrating humans. And I think the Hannover Fair is already going on for 4 days, and the whole halls are full of digitalization solutions. But if you look into industries, if you look into big companies and small companies, most of the infrastructures are still look like this. You have a very standardized ERP level, with some of the big players, and underneath on the shop floor there's still a huge variety of different IT systems. At some companies there are hundreds of different systems, and intralogistics is no exception. It's even worse there, okay? So what we have is a high complexity. We have no unified data usage and storage, and therefore a huge loss of efficiency and efficiency. So a situation we wanted to address, and we address it with a cloud-based solution, intralogistics management platform. We call it. So this is a SaaS-based solution. Underneath the WMS SAP layer where all the different interlogistics flows in a warehouse, in a factory are consolidated with a unified data infrastructure, so you can use AI and all the data analysis and optimization tools with defined interfaces, and of course a way clearer structure, centralized storage, and yeah, way less effort for implementation and scaling. So this is what we are doing. How is automation and intralogistics developing? You have a world where you have material flows that are mostly manually driven, okay? So you have forklifts, you have tugger trains, and if you go to the big fairs, you will see that that's still 90% of the industry. And there's always a big strive for automation. Why? Because you have to get more efficient, and in the Western world, especially the US and Europe, you have a lack of drivers, okay? So there's a huge shortage. You don't have people to show up at Monday morning, they don't want to work at the weekends, they don't want to work on night shifts, so therefore you are doing automation. But the first steps in automation are isolated. This is super important to understand. You have a case of automation at one hand of the factory, and then on the other hand they are clearly separated from each other, and this is how most of the companies jump into automation. But the need for efficiency and the lack of drivers push you to keep on going with automation, okay? And you're getting in more and more complex scenarios where you have a lot of different vehicles of different types, heterogeneous fleets. So you have forklifts, you have tugger trains, you have automated forklifts, automated tugger trains. Everything is driving around in one perimeter, and you need a platform like ours to really orchestrate that and optimize that. So with our solution, we are helping our customers to really optimize and digitalize and automate their material flows from manual material handling over isolated process automation, over mixed fleets into that world of very complex automated fleets with material flows that are manually driven and automated in one layout with overlapping transportation layouts with a very complex traffic management, and this is our approach. And we're all doing this with one platform, so we're bringing in our customers, helping in the transition into automation and the scaling and expansion of automation. And therefore, we built up a platform that is based in, has 4 different core functionalities or areas. First of all, I already talked about that is the mobile robot fleet management, so orchestrating all the different robots via standardized interface. I'm not stressing it today, but it's the VDA 5050. It's an interface that was developed by the German car industry and the German hardware manufacturers, which is now spreading around the world. It's applied in Asia and especially in the US. And then we opened up our platform towards storage in the warehouse and in the factory, but also towards manually driven material flows in-house, so tugger trains and forklifts. And all that is orchestrated on one platform. And with that approach, we totally changed the optimization approach compared to today's installations. Today, often in the planning process, you have a step-by-step approach. You look at a layout, you do an optimization, but then there's no continuous AI optimization of the whole layout. And this is exactly what we do. We are doing a continuous real-time optimization. We're taking all the data into account that's on the shop floor and always take it for the calculation of optimal solutions within the warehouse, within the factory, and this 200,000 to 300,000 times in a second. So we are calculating continuously the optimal solution, the optimal spread between transport resources and orders, and like I said, 200 to 300,000 solutions per second. So if you step in front of a robot, we instantly have a new optimal solution found for that factory, where we can replan that. If a machine breaks, if a human gets sick, if a tugger train gets derailed, we always instantly calculate a new optimal solution, and this is something totally new for the shop floor. This is only possible because you have that cloud technology and you have enough computing power to do so, and this leads to massively increased efficiencies on the shop floor. I brought you two pictures here. On the left hand side you see a resource utilization before an optimization with our software, where you see on the left hand side the numbers of vehicles. It could be forklifts, but also mobile robots. On the right hand side you see a more optimized fleet utilization with way less vehicles that are used for that. So this is an example from forklift, where it looks pretty much the same without that strict break time for mobile robots, and this really leads to savings of 50 or 60% of hardware, so capex, and in opex 70-80% as well. And I brought you, as the title of my talk is saying, some real-world applications. So one of them is from Volkswagen Commercial Vehicles here in Hannover, a factory that is 70 years old, so very, very old, very old layout, not made for automation. The legendary Bulli is built in this factory here in Hannover. The ID Bus right now is produced, and the Multivan T7. So there we are steering over 130 robots in the final assembly via that VDA 5050 interface. Okay, so that's the biggest VDA 5050 fleet in the whole world. There is a high variety on different intralogistics scenarios. So we have just in time, just in sequence. We have different, I will show you some pictures, different mobile robots. We have small lifting table, big lifting table. We have automated tugger trains, so Linde P250 tugger trains, which are driving around, which can be derailed by every human, and all that is automated. We have over 4,500 transport per day. And the last number is the most important and the number I'm most proud of. Only 1.1 robots per source sync relation. This is a number, this is in other new applications in the industry 2 or 3 times higher, because there we have an old planning approach where you have 2 to 3 or 4 robots on a source sync relation, strictly fixed on that and not optimized. And we are, like I said, always looking at all the robots, all the transport orders we have, and bringing them in one pool and optimizing the whole layout. And therefore we can bring down that number by to 1.1. So over 50% hardware savings compared to standard installations. And to be honest, in this layout, no other planning approach would have worked, because the streets are so narrow and traffic is so limited. So what we have those lifting table AGVs bringing containers and carts from the supermarket. So there's a supermarket where they pre-pack and bring them just in time, just in sequence to the lines in the final assembly. And then, as I said, we have Linde tugger trains, which are automated by, from the company Göttingen here, from the local region as well, which are driving from a local, separated logistic park and bring in material to the lines. We have an app in place. It's called the decoupling and coupling of the trailers is done by humans, and they have to be kind of optimized as well. So we are doing this with an app and optimizing humans as well. And I'm here. I'm showing you some pictures. This is the plant in Stöcken, only a couple of miles from here. And like you see, it's a very, very old factory where you have very narrow streets, where you have two-way traffic and a lot of different vehicles driving around. You see, this is one of the lines where you have the pre-assembly process in the supermarket, where the picking and stacking is done, and then it's driven to the lines. See here, like a packed rack with some material is put into place, and then it's picked up by the robots. Those robots are virtually line guided. They have some magnets in the grounds for orientation. They're from the company MLR, but they're virtually line guided, so we can reroute them with our backend tool. And they're now driving to bring the material to the assembly line. This is such a supermarket, and as you can see, there's a lot of traffic. There's cars driving around to rework. There's the finished cars are being pushed off. There's trains with visitors. There's the trash department is going through it. We have to evacuate in form of if we have fire alarms. You see layouts like this. They're not made for automation. We have a two-way street becomes a one-way street. So a very complex solution. This is only working because we use our software, we use our optimization algorithms, and we use the cloud technology to really optimize this. That factory has one or two of the worst intersections in the industry. So you see it on the top right corner. There is so much traffic that we have sometimes really traffic jams to be so, but we can resolve it with our optimization approaches, and it's really a very busy plant, and that intersection up there is, I think, the worst in the whole automotive industry. So this is, like I said, Hannover, Stöcken, and like I said, over 50% resources are being saved there. And then a different customer is Schaeffler. Schaeffler has a little different approach. They have 500 sites, not 123 or 24 like VW, but 500 sites, but they are way smaller and they're more heterogeneous, okay? You have a high number of different production processes, production forms, yeah, and therefore a high number of different vehicles. And for Schaeffler, therefore, it was super important to have a unified architecture. We provide here our solution as a SaaS solution from the AWS cloud. The scaling and implementation in the whole world is really done really fast. Within a couple of hours, 24 hours, we can have a new instant running with all the connection via MQTT to the order system, to the hardware, and highly scalable and ROI, since they're working over 2 or 3 shifts, often within 12 months. And again, those, especially brownfield factories, are very old. There needs to be a very good traffic management, and as you see, a lot of different hardware is being in place. Not the high numbers, not 130 robots, but 5 or 10 or something like that. But like a very diverse software. And you see here, we have no connection to an above order system, but we are often have our own order creator where the employees can call for new material, and then we provide them with that material based on our order creator. And you see a lot of different hardware and different manufacturers, lifting table, and this is our software we have here. And yeah, okay, that was from our side. Happy to answer questions if you have some, or to get into a talk. And yeah, thanks for listening.